let us move on to the next thing. The first derivation of your chapter, relation between focal length and radius of curvature. So for that one, basically in all your derivations, we will always be considering the first type of mirror, that is concave mirror. So let me just draw it how it looks like. Yeah, this is your principal axis. So this is your mirror that is there. I hope it is dark enough. Yeah, I could have drawn this before itself, but you need to understand how the ray diagram is happening. Yeah, just wait a minute. I'm not clear enough. Yeah, I hope now it is a little bit clear. Yeah. So this side will be the shaded portion, isn't it? Then what else? This will be your pole. Then let us say the first rule will follow. From the object, you have light coming this way. Yeah. Once it is incident at a point, then it will pass through. This is a parallel incident ray. It passes through the principal focus. It passes through the principal focus. Then center must be somewhere here, isn't it? Distances, I think you can write. Yeah. Now, also one more thing, from the center to the point of incidence, that is your normal, isn't it? I hope you remember. I have given the definition of what you mean by normal. Normal is the line joining center of curvature and the point of incidence. Yeah. So these are the things. Next, let us see what are the names that are given of from the source O. Where is it incident? It is an incident at point A. Then C. Okay, and the laser is coming out. B has been given the name. Then focal length and radius of curvature. This is your principal focus. So from here till the pole, yeah, you will be having what is called as focal length. Remember, this will be small f, this will be capital F, principal focus. Then center is over here. Just draw it from there to this point. From the pole to the center, it is radius of curvature. Now, center to A is the normal. This is the incident ray. So this has to be angle of incidence. And after reflection, it is passing this way. AB is the reflected ray. So this has to be what? R. Yes or no? And I know that angle of incidence must be equal to angle of reflection. Yes or no? Angle of incidence must be equal to angle of reflection. So this two I can write it as theta. Yes or no? These two I can write it as theta. Then from here to here, can you see there is a Z being formed? So I can write this one as theta. Yes or no? I can write this one also as theta. Why? When you have something like this, this was your 10th standard, I hope. Yeah. When you had an angle over here as theta, alternate angles you used to take this way. Z used to be formed, and this would become theta. Similarly, a Z is formed here, so this becomes theta. So let me write these two, because here there is not enough space. I'll write these as theta. Clear? So OAC, CAF, CAB, to be honest, is theta, and ACP is also theta. Now what about this guy? Okay, let me just, this much is complete. So first thing what we told, first step what we told is angle of incidence is equal to angle of reflection. That was the first step. Therefore I wrote angle of incidence is equal to angle of reflection. Let it be called as theta. Then I wrote ACF. Angle ACF is equal to OAC is equal to theta. ACF meaning this way. Yeah, to be honest, it should be ACP, because everything pole should be involved. ACP is equal to OAC is equal to theta. Why? it is alternate angles. Alternate angle. Yes or no? Next, what else can we do? If you can see here, these two are interior angles of this particular triangle, and this is the exterior angle. Yeah. So this is something like this comes from your basic. Again, from your schooling, you would have learned this. Yeah. Whenever these two angles are there, and this will be your exterior angle. These are two interior angles. This is your exterior angle. If this is theta and this is theta, then this one will be theta plus theta is equal to 2 theta. I hope this was learned in your schooling. So applying that over here, I think you can see here, this is the triangle. ACF is a triangle. AFP angle is the exterior angle. These two are the interior angles. Same triangle है, थोड़ा झुका हुआ है. Yeah, something like this would have happened. So no, that is how it is. Here and here you have theta. So this has to be obviously 2 theta. So if you are not understanding, just rewind a little and just listen once or twice. Yeah. Usually when I take your classes, I usually repeat things so that people can understand it and understand it better. So what you do, since we cannot repeat again and again in the video, we will tell it once. What you have to do, just go back, repeat it once again. So coming back to this, can I write AFP, angle AFP is equal to exterior angle equals sum of interior angles. So it will be CAF plus ACF. CAF plus ACF. Correct? AFP is equal to CAF plus ACF. AFP will be equal to CAF. CAF is theta. ACF is again theta. So this becomes 2 theta. I hope it is clear. This you are getting it as 2 theta. Understanding with this, I hope. So this is about your angles, the basic starting part. After this, I need to make this also a triangle. So the construction, I will draw this as N. After this step, I will be writing draw AN perpendicular to principal axis. Some of you had complained that when I am writing on board, I am not able to see, sir. So at least if you are not able to see whatever I am writing, I am telling it loud. Yeah. So better you listen and concentrate and then write. Just simply don't blindly sit and listen to your video. Just concentrate what I am doing. Look at the figure every time I am telling something. Still you are not able to follow. What you can do is, this particular figure is there in your textbooks also. Or just pause the video first, draw the figure at one end, yeah, and then start listening to the video. Don't write anything, just observe the video, observe the figure and keep listening to the video. Draw this figure in some rough note and keep referring, that way it will be easier. So draw AN perpendicular to principal axis. In your exams you will not be writing with this, it's just a shortcut I use. So you will be writing the full form. Done? So now, from triangle, I hope this is done. I'll just erase it off. You can pause and copy it down, then you can move forward with your video. Done. Let us move forward. From triangle ANC. From triangle ANC. Yeah? From triangle ANC, let us find out tan theta. अगर ये आपको दिखाई नहीं दे रहा है, yeah, what I can do then is also some space. Okay, that will be far away. This is how it is. This is dotted line. Yeah. So this is your A, this is your C, this is your F, and this is your L. P is somewhere close to this. Done. And this is your theta. This is also theta, and this is your 2 theta. Done? So same figure, you need not have to draw 2 times in your exam. Just draw this one, draw clearly. Coming to tan theta from triangle ANC. From triangle ANC, tan theta is equal to opposite by adjacent. Yeah, so here is your right angle, this has to be hypotenuse. Opposite by adjacent is here. Opposite is AN, adjacent is NC. Yeah, opposite is AN, adjacent is NC. Good enough. Then from this I can also write as, now look at this step. I can write if theta is small. If theta is small, I can write tan theta approximated to theta. I hope this was done in your first QC also. Whenever small angles are there, sin theta is approximated to theta, tan theta is approximated to theta, cos theta is approximated to 1. Yeah. So tan theta is approximated to theta. Why does that happen? Angle बहुत ही छोटा है, तो फिर opposite and adjacent जो है, it will match in such a way that tan function does not work so much. So this happens. So you get theta is equal to an by nc. This is your first equation. I hope these steps are clear. From triangle ANC, बड़ा वाला triangle we are talking about, tan theta is opposite by adjacent, an by nc. So if theta is small, it becomes an by nc. Done. Let us move on to the next particular thing, that is triangle ANF. Triangle ANF. So here only I know it, so that substitution will do. From triangle ANF. From triangle ANF, the smaller taller triangle. Yeah. If you see that, again let us find out tan to theta. Why 2 theta? 2 theta because triangle में है ही 2 theta. That's why you are taking triangle angle as 2 theta. Tan 2 theta again in this triangle. Tan 2 theta is opposite by adjacent, an by nf. An by nf. An by nf. Then again you will apply the same thing, same line. Yeah. If theta is small, only your line is. Again you will apply it here. So that becomes 2 theta is equal to an by nf. This is your second equation. 2 theta is equal to an by nf. So after this, 2 theta is equal to an by nf. Next, what else? Now theta is equal to an by nc, 2 theta is equal to an by nf. What I can do, this theta, instead of writing theta, I can write an by nc. So substituting 1 in 2. Substituting 1 and 2, 2 theta is equal to an by nf was second equation. In that I am putting first equation, theta substitute कर रहा हूँ. Theta what will happen? Theta will now become an by nc. 2 an by nc is equal to an by nf. So this is done. An can cancel. Yes. So what do you get here? From this thing I can write nc is equal to, cross multiply it, nc is equal to 2 times nf. nc is equal to 2 times nf. This is what you got from all that you just did. nc is equal to 2 times nf. Clear? Move on to the next part of it. nc is equal to 2 times nf. Now to equation 3, we are told nc is equal to 2 times nf. Yeah. If you see n is close to p. Now basic thing is, actually I should have started in the starting, I should have told all the directions that go on. We have one or two simple assumptions. One assumption is we always consider the aperture to be small. Aperture, I hope you remember, in your basic terms wala class jo tha usme I told this particular thing as D I had written. The aperture, the effective diameter where reflection takes place is called aperture I had told. तो आमतौर से क्या करते हैं derivations में we tell the lens is not, sorry, the mirror is not bent too much. We will say it is bent lightly. So the aperture is small. The area of reflecting surface is less. So we consider that way. If you see it that way, and the other thing we tell is the angles can be considered to be small angles that we have already used. If theta is small, if the angles are small, then tan theta is approximated to theta. So this particular thing, if aperture is small, if aperture is small, yeah, I can write n is close to p, n is close to p. Why is n is close to p? Because ये छोटा हो जाएगा, a is close to p. If a is close to p, n will also be close to p. That's why I hope you understand. अगर ये effective diameter छोटा हो जाएगा, a will be coming closer to p. If a is coming close to p, perpendicular from a will also come close to p. तो जैसे जैसे a नीचे मूव करता जाएगा, n जो है p के तरफ मूव करता जाएगा. So that's why n is close to p. So nc can be now written as pc. N is now written as p. nc becomes pc. 2 times nf becomes 2 times pf. pc is equal to 2 times pf. Is this visible? pc is equal to 2 times pf. Done. Now comes your most important part जो आपने थोड़ी देर पहले सीखा, that is sign convention. From sign convention PC, what will PC be equal to and what will PF? What will PF be equal to? Yeah? Think about it. PC is written, if you come to this figure, PC, from the pole to C, PC we know that it is R, but P से पीछे जाना है, incident ray is this way, so I will not write just R, I will write PC is equal to minus R, yeah, and PF, P to F is focal length small f, yeah, but will I write just F? Just from pole to the principal focus, going opposite direction to the pole के pole से लेकर हमें f की तरफ जाना है. We are going opposite way to the incident light, so it is minus f. Clear? These things are really important. So substituting these two over there, we can put the name equation 4 होगा ये. Substituting the sign convention in equation 4, you write that by yourself. So it becomes PC is minus R is equal to 2 times. Yeah, 2 times. PF is minus F. Don't forget to put the bracket. There are a lot of students who do not put the bracket. They think it is 2 minus F. Then the intermediate gets the equations there. So minus and minus get cancelled. Yes. So you got F is equal to R by 2. F is equal to R by 2. That is the relation between focal length and radius of curvature. So this is one simple derivation. What and all did we do? I think you have written it down in your books, classworks right now. I'll be checking them later. Yeah, and your attendance will be checked, your classworks will be checked, your homeworks and assignments will be checked. All this thing will be done through your internet itself. Yeah, it will be done digitally itself. Later I'll tell you how it is done. I think introductory class that I have told. Now come to this. I'll just repeat what and all we did. Just go through what we have done. Just look at your book. Here, first thing, the relation between focal length and radius of curvature. In this we learned, we first drew a concave mirror. Yeah, let OA be the incident ray. Let OA be the incident ray passing parallel to the principal axis. Then after incidence, it passes through the principal focus F. So AB is the reflected ray. So let theta, or should I say this OAC, is actually I. Angle of incidence I have written it as theta. Angle of reflection also I have written as theta. Yeah. Then from law of reflection, angle I is equal to angle R. Both are equal to theta. Then OAC is equal to ACP. Why? It is alternate angle. So this and this will now I will be equal to theta. So these two are theta. After that, considering triangle ACF, sum of interior angles must be equal to exterior angle. Therefore, AFP is equal to CAF plus ACF. So AFP becomes theta plus theta equals 2 theta. So once your angles are now solved, let us draw a perpendicular AN perpendicular to the principal axis. Done. After drawing perpendicular, then from triangle ACN, you can take the bigger triangle, apply tan theta. Then you can take the smaller triangle AFN. From that you will take tan 2 theta. Then you will write the sides that are there opposite by adjacent. You will write. After writing that, you will tell theta is small. So tan theta becomes theta. Tan 2 theta becomes 2 theta equals so and so. After that, you will just substitute the first equation in the second one. You will find a relation. Then what will happen? Then we will tell n is close to p. If aperture is small, n is close to p, you will tell I have written there n is close to p. So wherever n is there, replace it with p. I hope this step is clear for you. n p से क्यों replace करना है? अगर ये bending कम होता है, then this perpendicular will come close to p. Yeah, or should I say the effective diameter reduces, then n comes to p. That's why n is written as p. So it becomes PC equals 2pf. After that, we need to use from sign convention PC. PC is from the pole to C. Even if you had written CP also, still you will always write CP का मतलब क्या है? In the diagram, you will have to always go from pole to whatever the point is. So CP or PC, whatever you write, some P to C is actually R, but it is going in the opposite direction. I am reaching the distance in the opposite direction to the incident light. So I will be writing it as minus R. Similarly, PF will be equal to focal length, so that is minus F. So substituting that, we will come to the relation F is equal to R by 2.